Hi everybody, in this video let's look at direct variations. Okay, if the question tells you y varies directly as x, right? We can write it this way. This is variation relation. If you want to write in equation form, then it will be y equal to kx. We add a k in front of x. So this is equation form. So when you look at this equation, I think you will recall back this, right? Y equal to mx plus c. It's a straight line. This is a straight line as well, but this time there's no c here. So it means that if you draw a graph y against x for this case, you will get a straight line passing through the origin. And the k here is actually the gradient of the graph of y against x. Okay, you look at this equation. When I divide both sides by x, what will happen? Y over x is equal to k, right? So, if sometimes the question asks you, is the y varies directly as x? So how to determine? It's very easy. You just take the y, the value of y divided by x. If you always get a constant, you always get the same number, a constant, then we can make a conclusion that y varies directly as x. If not, y does not vary directly as x. Let me give you an example. Now, let's say I have an equation y equal to 2x. Okay, let me control a table and give some value to x, and then we calculate the value of y. X, y. 1, 2, 5. Okay, let's try one more, 10. When x is equal to 1, 2 times 1 you get 2. When x is equal to 2, 2 times 2 you get 4. When x is equal to 5, 2 times 5 you get 10. When x is equal to 10, 2 times 10 you get 20. Now, you will notice that whenever you find the value of y over x, 2 divided by 1, 4 divided by 2, 10 divided by 5, and 20 divided by 10. In this case, you will always get 2 is a constant, right? So, y varies directly as x. Okay, let me show you another characteristic of direct variation. So try to look at the value of x here from 1, let's say from 1 to 5 times 5, right? The value of y will change in the same manner, times 5 as well. 2 times 5 get 10. When the value of x from 5 to 10 times 2, the value of y changes the same manner as well, times 2. This is another characteristic of direct variation. Okay, so this is a graph that I mentioned just now. If you draw this graph, y against x, you get a straight line. K is the gradient of this graph, and this straight line will pass through the origin. Okay, you will always see this graph. This graph is a positive gradient. But if the question gives you a graph like this, for example, y against x, and the graph is going downward like this, and the question asks you, is y varies directly as x? The answer is yes, as long as this straight line and pass through the origin. But why you seldom see this graph? Because in this case, you will notice that the y is negative, right? In our real life situations, for example, like the number of days, the number of hours, our body mass, salary, and so on, always will be positive, right? It cannot be negative. The minimum can go is just 0. That's why you always see this graph. Okay, now the power of x not necessarily need to be 1. It can be 1 over 2, it can be 2, and so on. So let's say if I tell you that y varies directly as, okay, this time we don't want x anymore. Let it be y varies directly as x squared. So this is variation relations. Okay, this one. If I want to calculate, right, we always change it to equation form. So y is equal to kx squared. So just now I told you that if you want to test whether y varies directly as x or not, you find the value of y over x, right? If you always get a constant, we can make a conclusion that yes, y varies directly as x. So in this case, if I want you to test whether y varies directly as x squared or not, so what you should do? You take y divided by x squared. Why we do it this way? Now, we look at this equation. Y is equal to kx squared, right? If I divide both sides by x squared, what will happen? Same as just now, what I did just now. Here you get k. You will notice that whenever you take the y divided by the x squared, you always get a constant. If this happens, it means that y varies directly as x squared. So how about if I ask you to draw a graph y against x for this situation? Will you get a straight line which pass through the origin? No, you will not get a straight line. Why? Just like I told you that you should get a straight line passing through the origin, right? This case is y varies directly as x. In this case, y does not vary directly as x, but x squared. That's why if you draw a graph y against x for this situation, you will not get a straight line. If I change it to y against x squared, yes, I will get a straight line, and the k is a gradient for this straight line. Okay, this power is not necessary to be 1, 2, it can be 3, it can be square root, and it can be 1 or 2, it means square root. Okay, until now you might be still not very clear, a little bit confusing. It's okay. Let me give you some example. After that, I think you should be able to understand better. Okay, let's look at some example. Okay, let's look at this example 2. It's given that the x kilogram of rice costs RMY. The relationship between the value of x and y are shown in the table of values above. So it is a table. The question mentions, determine whether y varies directly as x. Okay. The question asks us whether y varies directly as x. So still remember what I told you just now. Y varies directly as x. We can write this way. This is variation relation. So if I want to write in equation form, then it will be y equal to kx. From here, I know that if y varies directly as x, y over x will be equal to a constant, right? So if I want to determine whether the y varies directly as x, it's very easy. I just need to find the value of y over x. If I always get a constant, then the answer is yes. If it's not, we get sometimes 2, sometimes 3, sometimes 4, and so on, then the answer is no. Okay, what we need to do is just how about just add over here, add one more row over here, and then let's find the value of y over x. Okay, can you see it? This is okay. How about I write over here? You can see it clearer. Okay, so I have copied the table x, y, and now we want to find the value of y over x. 9 over 3, you get 3. 15 over 5, you get 3. 18 over 6, you get 3. Same thing here. Okay. Oh, all the value of y over x is equal to true. It's equal to 3, and it's a constant. Y over x is a constant, right? Therefore, we can make a conclusion that yes, y varies directly as x. If you don't want, you can just copy this one. Y varies directly as x. Okay? Okay, now let's try another example. Okay, now in this case, by drawing, now the question don't want us to calculate like just now what I showed you. The question asks us to draw a graph and to determine whether the y varies directly as x squared. Okay, this time it's not x, but x squared. So let's say in the exam, if the questions does not ask us to draw a graph, normally we will not prefer to draw a graph because drawing a graph takes a lot of time, right? So let's say in this situation, if I don't want to draw a graph, how do I test whether the y varies directly as x squared? Okay, y varies directly as x squared. This is variation relation. If I want to write this in equation form, then it will be y equal to kx squared. So I know that y over x squared will be equal to a constant. If I take the value of y divided by x squared, I always get a constant. Then I can make a conclusion that yes, y varies directly as x squared. If not, then y does not vary directly as x squared. But in this case, the question asks us to use a graph method, then we will need to use this method. Okay, so after I draw the graph, I will show you this method to test is varies directly as x squared or not. So since we want to test y varies directly as x squared or not, we need to draw a graph y against x squared, not y against x. So I have an x here. How do I get the value of x squared? It's very easy actually. You just take all this value is squared, then you will get x squared. Okay, so if I want to get the value of x squared, I just take 1 square, you get 1, 2 square 4, 3 square 9, 4 square 16, 5 square 25. Okay, now I'm going to draw a graph y against x squared, not against x, but against x squared. So y axis over here and x square axis over here. Okay, so I have labeled the axis, both axes. Now we can start to plot. When x squared is equal to 1, okay, so it's a little bit hard for me to get it here. Okay, so you can try to draw a graph and try to plot it yourself because here it's too small. Y is equal to 1, 1 is over here, and x is y is equal to 2, y is equal to 2 should be here, right? Okay, and x squared is equal to 4, 4 here, y is equal to 8, y is equal to 8 should be here, okay, right? And when x squared is equal to 9, y is equal to 18, 9, 18. Okay, so when x squared is equal to 16, y is equal to 32. And last one, when x squared is equal to 25, y is equal to 50. Okay, this one should be easier. Okay, the next thing is to draw the graph. Connect all the points together. If I get a straight line which pass through the origin, then we can say that yes, y varies directly as x squared. If not, then y does not varies directly as x squared. Okay, what happened? Cannot draw them. Okay, let me try. I think something wrong here. Okay, let me take this. Okay, now okay. Let me connect all the points over here. Yes, I get a straight line, right, passing through the origin. So I can make a conclusion that y varies directly as x squared. So as I told you just now, if you don't want to draw this graph, you can actually use this method. But in this case, you have to look at the requirement of the question. If the question asks you to draw a graph, you have to follow. Okay? So now how about we try another method? We take y over x squared. Y over x squared, you get 2. Y over x squared, you get 2. All the same thing, right? So we can make a conclusion, yes, y varies directly as x squared. Okay, now let's try another example. Given that y varies directly as x, so when I see this, I write this first. Y varies directly as x. If I want to calculate, right, we always change it to equation form, which is y equal to kx. Okay, now write the direct relations in the form of equation. It means that we want to write in this form by first finding its constant of variation. Okay, the k is constant of variation. I forgot to tell you just now. Okay, hold on. The k here, right, is a gradient of the graph, and it's also called the constant of proportionality of all. This is not of all. Constant of variation. Okay, this is the name for the value of k. Okay, let's go back to the question just now. Yes, here. So what I need to do is find the value of k, then write an equations, then that will be the answer for this question, right? So how do I find the value of k? I know that if I want to get the value of k, I need the value of y and also the value of x, right? Okay, so we have to look at here. These two values given by the questions. When x is equal to 32, y is equal to 24. Y is equal to 24. So now I'm going to plug in these two values into here. This is y and this is x. Okay, y is equal to 24. Is equal to k. I don't know the value of k. Now I want to find it. X is equal to 32. So if you want to find the k, it's very easy. You just take 24 divided by 32. So you can use a calculator, or you can just simplify it this way. Divided by 4, divided by 4. How about I divide this by 8. 384. Okay, so I will get 3 over 4, but I cannot stop here because the question asked me to write in the form of equation, right? So I have to write y is equal to 3 over 4 x. So this is the final answer for this question. Okay, now let's try the example. Given that p varies directly as the cube, okay, be careful. You have to look at the word here. So some students, they will just look at the variable. They see p varies directly as the cube of r, but it's just they just look at this p and r, right, this way, and then become p is equal to kr. This is not correct. It's not correct. So you have to focus on, you have to look carefully the questions. The cube of r, so it means that I have to put a power 3 over here. Same thing here. Okay, now we want to calculate the value of p when r is equal to 10. Here we have two methods. I'm going to show you two methods. How do we get the value of p? So first, the first method is I get the value of k first. If I want to get the value of k, I need to use these two information given by the questions to help me to get the value of k. Then I will have an equation. When r is equal to 5, p is equal to 75. I'm going to plug in this value into here and here. P is equal to 75 is equal to k times r power 3. So this is 125, right? 125k. So k is equal to 75 over 125. Just press the calculator. 75 divided by 125 is 0.6. If you don't want, you want to write in fraction, 3 over 5 also can. So here I think I will just write 0.6. Okay, now I have an equation. P is equal to 0.6 r cubed. Okay, so I'm going to use this equation to help me to get the value of p. When r is equal to 10, so p is equal to 0.6. I copy the equation first so you can see it clearer. P is equal to 0.6 times r cube. Okay, so here just press the calculator. This 1000, it will be 0.6 times 1000 will be 600. Okay, so this is the answer for p. If you don't want to use this method, we can use another method. Okay, let me show you here. P is equal to kr cube, right? So if you move the r cube over here, you divide both sides by r cubed, you know that the value of p divided by the value of r cubed, the cube of r, will always equal to a constant. So if you know this concept, we can use this information and this to help me to get the p. Okay, p over r cubed. I don't know the p, I just write p first, over r cubed. R here is 10, so it will be 10 cubed. So here p is 75. R cubed will be 5 root the power of 3. Okay, so this is 3. Okay, 3. So the next thing, you just take 75 divided by 125, which is equal to r 5 cubed, times 1000. You try to press the calculator, you will get exactly the same answer, right? 75 divided 125 times 1000. Okay, so the answer is still the same, 600. So you can use this method or this method, is up to you. 2 will give you exactly the same answer. Okay, now let's go to B. Okay, this is the equation that I got just now, so I can also use this equation for part B. P is equal to 0.6 times r cubed. When P is equal to 16.2, so I need to find R. P is equal to 16.2 R cubed. So R cubed is equal to 16.2 divided by 0.6. I'll get 27. So if I want to get the value of R, I have to cube root 27. R is equal to 3. Okay, so this is the way how we solve the question for direct relations. Okay, for this video, I think I'll stop here first. I will see you in the next video. Thanks for watching. Bye bye.